Okay, so let's continue with the forward and reverse biasing of PN junction diode, as we are already familiar with the theory that this is the symbol of the diode, in which this shows the anode are positive, this side shows cathode are negative. And this is the basically internal understanding of the holes and electrons within the PN junction diode. And these are the circuits, and this is the table which we have to fill and then plot the same in order to understand this phenomena. So we have to start the supply voltage from 0, slightly increasing by 0.1 volt till 1, then 2, 3, 4, 5. So we will observe that in case of silicon diode, it will not conduct, or it will conduct in a very small amount before 0.7. After 0.7, its conduction or the current will increase rapidly, while the voltage across diode will remain around 0.7 after this supply voltage, whatsoever is, and current will increase proportionally after 0.7 volt. So let's continue to build. So we need a variable voltage source because it's very difficult to continuously change the value of voltage by entering. So we will take interactive or sources and DC interactive voltage. So this is variable DC voltage. And the beauty of this is that we can control this with any of the key that we assign. So for example, we want it to start from 0, and we are setting it as that it's, let's say its maximum value is suppose 100, and we want that it should be increased in the portion of 0.1 volt, so that becomes 0.1%. Okay, so now its assigned key is A, which could be changed from here. So with this key, this would be varied in this pattern like this, like this. Okay, so this will be very easy for us to perform the simulation. Similarly, we can come back with shift A. Anyways, okay, let's take a diode. So diodes, and now within the diodes we have many models. Usually we use two models, 1N4001 or 1N4007. Let's see both of the models and use any one of them. So 1N4001, if we will open it, this is rated for 1 ampere, 50 volt standard rectifier. If we will come towards the edit model, we will find its breakdown voltage over here. So its reverse breakdown voltage is 50. So after 50 volt in reverse direction, this will break down. While another diode 4007, this is rated for again 1 ampere, but voltage is 1000. So we can see its breakdown voltage, and its breakdown voltage is 1000. So this has maximum breakdown voltage of 50. This has maximum breakdown voltage of 1000. So let's use this one. Very simple, because our lab handout is designed as per this diode. If we see, in forward it's okay, but in reverse the voltages are 10, 20, 30, 40, 50. Till 50 this will be okay, or maybe it could break down, but of course at 100 this will surely break down in the reverse bias. So let's use this diode and let's use a resistor as a load. So the purpose of diode is to flow the current in one direction, while the resistor that we will use now will act as a load. So this is the resistor. And this is a very simple circuit. Still, we have to add the meters in this circuit. We want to measure voltage across diode, current through diode. No need to measure supply voltage, because supply voltage we are supplying itself, that is visible here. Current, because this is a series circuit, so current through diode resistor, that will be one, that will be same. So connect a meter in series, delete this wire and attach a meter, and let's set this meter on ampere, and of course this is DC. Another meter for voltage across diode, so connect it across diode, open it, this is already set at voltage and this will show us the voltage. So ground for the requirement, and the circuit is completed. Now as we will run it, so we will observe at 0 volt, 0, everything is 0, voltage is 0.1. So this complete voltage is appeared across the diode, that is 0.1 volt means 100 millivolt. So 99.9 millivolt appears across the diode. Only minute amount of current flows, the unit is nanoampere. So this is very important. Because this is nanoampere, so this is very minute current, and that is due to the minority charge carriers. So 0.2 volt. Similarly, still current is very small. Still current is small. Still. What we have to do, we have to note all these readings. So let's say 0.6 volt, voltage is 447 millivolt. So let's say we have to record it in table. Suppose at 0.6 volt, the voltage is 0.447. Okay. Similarly, current is 152 micro. Let's put all the currents in just ampere. So 0.000152 like this. Okay, so let's see 0.7 volt, and this is the point from where the diode will start its conduction, and we can see it from the value of current. At this point, the current is microampere still, which is negligible. Now, at 0.8 volt, 0.9 volt, and 1 volt, the current is increased. This could be treated as half milliampere because this is around 500 microampere. So this could be treated as 0.5 milliampere. And we can notice the diode drop, the voltage drop across diode is now around 0.5 volt. So 0.7 is a standard, but it's not necessary. This should be exactly 0.7. That could be around 0.5, 0.6, 0.7, 0.8, like that. So let's increase the voltage furthermore. Now, as we will increase the voltage furthermore, current will increase proportionally. So now see, the current is in milliampere, and that is a sufficient current, but still the voltage across the diode is around 0.5 or 0.6 volts. Similarly, so on, as we will increase the supply voltage, now only there will be increase in the current, but not in the voltage. Okay. Now, what you have to do, you have to record all these readings in this table. Okay. After putting all these in this table, we have to plot these two things in Excel, just like Ohm's law. So we will get the curve of forward characteristics. Which curve? That we have discussed in our class. A curve like this. So we will get this part of the curve that is in the forward bias. So till 0.7 volt, there is very minute amount of current. After 0.7 volt, there is a constant increase in the current with slight change in the voltage. While in reverse bias, now let's try the reverse bias. Okay, having a copy of this design. So let's copy this design to new one. And what we are doing only that we are only changing the direction of we can either change the direction of diode or we can change the direction of the supply. So it's as per our simplicity or our convenience, we can do this. So let's connect the diode in the opposite direction. Now this is reverse bias, and let's again start the voltage from 0 and let's run it again. So now because this is reverse bias, so again uh, in reverse bias, there is very minute amount of current due to minority charge carriers, while the whole supply voltage is appearing across the diode. That means the resistor gets nothing. This is the load and load gets nothing. So this is how the diode blocks the voltage in reverse bias direction. So let's say we have supplied 10 volt and complete 10 volt is appeared across the diode and very minute amount of current which is nanoampere. If we compare it with the forward bias, so in forward bias around after 1 to 2 volt we had the current of milliampere which is sufficient. So it's still increasing the voltage. So 30 volt, complete 30 volt across the diode, still current is nanoampere which is almost zero. Still increasing the voltage. We know its breakdown voltage that is 50. So of course around 50 volt this will break down. That means it will not further block the current in reverse and this will be damaged. Although this is simulation, but in hardware, if breakdown voltage is reached, the diode will be damaged. So 40 volt, same 40 volt across the diode, still current is nanoampere. Is still increasing the voltage. So 50 volt, at 50 volt, still current is nanoampere, but as we cross 50 volt, now current is changed from nano to micro. Further increasing from 50 volt, current is increased in microamperes. Further increasing the voltage, now the diode is in breakdown condition. So current is in milliampere. From nano to micro, now in milli. And we can see the voltage across the diode has limited to 50 volt because this has in breakdown condition, and as we will further increase the voltage, there will be further increase in the current while voltage across diode will now remain at 50 volt, which will show that this is in the breakdown condition. Okay, so 100 volt is supply voltage. Voltage across diode has limited to 50 and the current is 49 milliampere, which is showing the breakdown condition because the diode is in reverse bias and it should not conduct. So with this, this is completed. Although this is the simulation part. So this is using multisim, forward and reverse bias. Same we will do using hardware. But in hardware, for forward, this is okay. We will go up to 5 volts. However, in reverse, using hardware, we cannot go beyond 12 because we will use Elvis kit. And in Elvis kit, with the variable voltage, we have the maximum limit of 12 volts. So anyways, we will observe that till 12, it will not conduct. And there are few questions. Here we will attach the graphs that we will use, that we will plot using Excel. And there are some questions for you that why silicon preferred over germanium, PN junction, knee and breakdown voltage. What are these terms? They are explained over here. This is knee voltage in forward bias from where it conducts. This is breakdown voltage in reverse bias from the point where it breaks down. And what are pentavalent and trivalent impurities? So these are just for the repetition purpose. With this, we complete this lab. So further, we will continue it in our hardware setup.